Hello and welcome to the next session of Introduction to Autonomous Systems. If you recall, in the last segment we introduced the idea of entailment followed by the process of arriving at an inference, and we came to the important conclusion that the algorithm which is going to do this job for us needs to be sound as well as complete. Even though we realized that in some situations it might not be possible to ensure the completeness, but it is extremely important to establish the soundness of that algorithm. Let us now continue the discussion and bring in another requirement on that algorithm in the form of grounding. So, let us begin today's session. It is the last prerequisite of logical inference, which is called grounding and is considered as a process for knowledge based building. What we are trying to say indirectly is that we now are trying to find a connection between the logical reasoning and the real environment. In fact, this is equivalent to asking this following question, that how do we know that knowledge base is true in the real world? We have no knowledge. We have to establish that the knowledge base that we have created, is it true in the real world? Because if you go back and look at our inference process and the entailment exercise that we have seen, it makes a very important stipulation that if the knowledge base is true in these collections of model, then the inference is also true in them collection of model. So, we go back to this basic idea that is the knowledge base true in all the models, or what we call the real world. In fact, many people say this is a somewhat philosophical question, but in terms of operational scenarios, we say that this particular connection is typically created by sensors that interact with the real world and provide a glimpse of what is actually happening outside, and now realize the importance of sensors, which means as human beings, if you know, our appreciation of the real world is through our senses, what we see, what we hear, what we taste, what we touch, we feel hot, we feel cold through the skin. So, all these are essentially information that are provided by the sensors. So, which means now we are saying that information which is coming from sensors is in some sense representing the truth of the real world, and if the knowledge base is created using these sensor information, then there is a possibility that the knowledge base will actually represent what is happening in the outside world. As I was just mentioning, if the agent program creates a suitable sentence based on the input given by the sensor, we know that if that sentence is part of knowledge base, then that knowledge base will be true in the real world. And that also brings us to an important requirement on sensors to as correctly as possible capture the real world. And this is where you will find that the quality of sensors and their ability to capture information correctly will become extremely important for constructing a knowledge base which is going to be true in the real world. And now we realize that the meaning and the truth of percept sentences, see, we have to go back to our basic problem that we are looking at. The sentences which are constructed for the knowledge base from the percepts or the sensor input, essentially if that is what we ascertain as a truth and use the basic process of syntax and semantics, then we know that this is what we need to do in the context of our knowledge base building exercise. And then once we establish that this knowledge base is true in the real world, because I am sensing the real world at whatever rate that is required for that problem, and I am able to get all the information that is necessary for me to come to an inference. And this also brings us to an important connection that we need to understand. If you recall, in one of the earlier sessions, we introduced the idea of learning agents, and we said that the learning is equivalent to generating more information, correct information, and if those sentences are correctly formed and they are based on the real world scenario, then the sentences created through this process, if they go back to the knowledge base, then that is where your knowledge base will continue to expand but remain true to the real world. And again you realize that in order to ensure that the sentences that you create from the learning exercise are based on good and robust learning procedures. So, when we use such procedures to create sentences that go and enrich your knowledge base, then we ultimately get good knowledge bases, and you realize that it is only the goodness of the knowledge base which will ensure that your entailment process is as it should be, and that the inference that you draw based on a sound procedure will be the correct inferences, and it will logically follow that those inferences will represent the correct action, or what we have started initially discussing, intelligent rational agent, that it is doing the right thing, which is an essential part of a rational agent. Now, to do all this, we have to bring in some elements of those algorithms which are going to ensure the soundness of whatever inference process that we are going to look at. And one such tool in creating the knowledge bases that are going to be logically true is the discipline of propositional logic. I am sure many of us have at some time or the other dealt with the propositional logic in different contexts. Let us now understand this propositional logic in the context that it is going to help us to create sentences which are going to be logically true in the context that we are interested in. Look at the very basic interpretation of propositional logic. It is a simple yet very powerful tool to determine truth of any sentence. This can also be used for the entailment exercise, that is deriving sentences from other previously entailed sentences, and that is where the propositional logic gets into our whole process of building knowledge bases, that the whole exercise of entailment, which involves establishing the truth of a particular inference, is essentially driven by the whole idea of a propositional logic, as we have been talking about earlier from the language perspective, there are two basic components, the syntax and the semantics. Syntax establishes that the sentence is properly formed, and semantics says that this statement is true in the real world. Now, let us look at the propositional logic syntax, and that syntax establishes or demands the construction in a particular manner, so that the sentences are well formed and are allowable to be processed further. So, before we proceed with that, let me also introduce another idea of what we call atomic sentences, which in the context of propositional logic are those sentences which consist of a single propositional symbol, where each symbol stands for a proposition that can be true or false. That is one single propositional symbol. So, these are called atomic sentences, which means basically building blocks. Now, you could put them together and construct more complex sentences, as we shall see when we proceed forward. And there are some conventions which are commonly observed in the context of propositional logic related sentence construction processes, where we use uppercase letters along with subscripts as propositional symbols that represent sentences. In addition, we have already seen it, but we again want to reiterate that there are two propositional symbols which have the fixed meaning. True is always true in all contexts, all models, and false is always false. So, those are also two symbols apart from other propositional symbols that are there to create sentences. Of course, we also employ parentheses, logical connectives, and use all that to create more complex sentences from simple sentences. So, if we were to kind of summarize this whole game, we have three things. One, two propositional symbols which are always true or always false, the true symbols. Then we have additional propositional symbols which can be used to create atomic sentences, and then parentheses and logical connectives which can construct complex sentences from simple or what we call atomic sentences. As per the logic syntax, there are a total of 5 logical connectives that are in common use, as we shall see one by one next. The first one, the logical connective, is not. Its symbol is a horizontal line with a small vertical extension at the right end. The way it is interpreted is that a sentence with this symbol preceding that particular statement, P is what we call our sentence. So, not P is called negation of P, which means whatever is P saying, not P is opposite of that. So, if P is false, not P is true, or if P is true, then not P is false. That is the way it is to be interpreted. The next logical connective is AND, indicated by the upper caret, and this particular is used in the form of a sentence P and Q, and it is normally called conjunction, and its parts, that is P and Q, the two sentences, are called conjuncts. We will talk more about this as we look at some examples later. The third logical connective is OR, which looks like a V, and the sentence is P or Q essentially is called disjunction, while its parts, the P and Q, are called disjuncts. So, it will appear that and or are kind of complementary to each other. Then we have the fourth logical connective called implication, which is two horizontal line with a arrow sign at the right end. This is symbol which is used to indicate the implication, and a sentence which is given here as P and Q put in parenthesis implies not R, and is called either an implication or a conditional. These are the terms which are used to describe such a construct for a logical sentence, that P and Q together imply not R, and we say that P and Q here is a premise and R is the conclusion. Let me take a pause here and now establish the connection of this particular connective to our knowledge base building. Now you can clearly see that this is what is going to be required when we want to come up with a conclusion. And now you could say that your premise P and Q could be a very complex combination of the statements which are part of the knowledge base, and with a large number of logical connectives it will imply a conclusion which is not R, and then you say that you have found the needle in the haystack. Fifth one is the if and only if condition. In textual form it is represented as IFF. In terms of symbology, it is the double headed arrow, or sometime three parallel lines are used to say something like equivalence. So, if and only if IFF, the double headed arrow or the three symbols, all of them mean the same thing, and the interpretation is that P if and only if not Q is called the bidirectional. So, this is the implication of this kind of a logical connective. Now, let us, so those were the elements of the syntax, that the well formed sentences will use those 5 logical connectives to create sentences which are logically or syntactically correct. The semantics now define the rules for determining the truth of a particular sentence with respect to a particular model. So, in the context of propositional logic, it simply fixes the truth value, that is true or false, for every propositional symbol. That is all. This is the whole exercise, that the semantics essentially is trying to fix the truth value. Of course, you know that this is not going to be very difficult for atomic sentences. For example, as we say, true is true in every model and false is false in every model. For complex sentences, we are going to require now additional rules, because it is not going to be very straightforward. So, for complex sentences, there are a set of 5 rules that are to be applied for finding out the truth value or establishing the semantics, and hold good for any 2 sentences P and Q in any model. So, we say not P is true if and only if P is false in M. You can see now where that if and only if is being used. That is the logical connective which says that not P is going to be true only if P is false in M. Then we say P and Q is true if and only if both P and Q are true in M. And immediately you realize that if one of them is false, P and Q will not be true. P or Q is true if and only if either P or Q is true, which means we are saying that only one of them needs to be true. So, if P is true, it is fine, if Q is true also it is fine, and if both are true also it is fine. That is how an OR symbol is interpreted. it will become false only when both P and Q become false. And when we say P implies Q will be true, but it will not be if P is true and Q is false, which means this will imply only if Q is true and P is true. In all other cases, it will not be applicable. And the bidirectional, we say P is equivalent of Q if and only if both P and Q are either true or false. And you can understand the implication now, that a true statement will imply another true statement and a false statement will imply another false statement, and not vice versa, that if true statement cannot imply a false statement or a false statement cannot imply a true statement. That is why if both P and Q are true, then only they are equivalent, or if both of them are false, then only they are equivalent. And this has brought in an idea of the truth table, which I am sure all of us have been exposed to even in our school days, about how to put these 5 rules so that it now checks all possible models in the context of any 2 sentences. It is just an example to show what are the possible models that will be applicable for 2 statements P and Q. So, as you can see, P can be true, Q can be true, P can be false, Q can be false, and they can be all these together or at different times. So, that is going to be the dimension of the models which we will have to look at. Let me show you the table. So, there are 4 possibilities. P can be false, Q can be false, P can be false but Q can be true, P can be true but Q can be false, or both P and Q can be true. So, for a 2 sentence statement, there are 4 combinations, that is 2 to the power 2, because there are 2 sentences and there are only 2 states possible, true or false. So, basically there are 4 possibilities that we need to establish. So, we clearly see that not P will be true in the first case, second case also will be true, in third case both will become false. Now, if we say P and Q, it will remain false in the first 3 and will become true only in the fourth case, that unless both P and Q are true, P and Q will not be true, the conjunction. On the other hand, when you say P or Q, except for the first one, all the 3 will be true, because one of the sentence is true. So, this disjunction will be true. When we say P implies Q, false will imply a false, which is true. Then false will imply a true, it can be true. True can imply a will not imply a false, so it becomes false, and true implies true, that becomes true. So, implication indicates that there are 3 true and 1 false, whereas the bidirectional has only 2 true situations, that false implies false and true implies true. So, most of the time you will realize that you will be required to use bidirectional to ensure that your knowledge base is actually getting the correct kind of statements. See, apart from these 5 rules, we also sometimes use what is called exclusive or XOR is the textual symbol for it, and the graphical symbol is a circle with a plus sign in between. And when we say P XOR Q, this sentence is false if both P and Q are true. Yes. So, basically if both P and Q are true, your P XOR Q becomes false, that is exclusive OR, which means it does not admit that one possibility of OR that we have seen, that if you look at the 5th column, Here if you say that if both are true, it will become false here. So, this is the implication of the exclusive OR. With that we come to the end of this particular segment, which to conclude, propositional logic is an effective way not only of arriving at truth or falsity of a sentence or a statement, but is also a sound method, which means if you remember we were talking about an algorithm to find out an inference from knowledge base using the entailment process, and now we have established that one of the sound algorithms is going to be our propositional logic. And we have also seen that logical connectives provide a way of arriving at more complex sentences from simple or atomic sentences. We will proceed further with this and bring in more ideas as we go along, but at this point we conclude this particular segment, and thank you for your attention. Bye and see you in the next segment.